All right, guys, this is our next set of notes that are going to go into our spiral notebook. So it does kind of say get out your spiral. If you want to complete the notes first and then tape them or glue them in after you have completed them, that is fine. This will be checked on my return, and also I will check it online through your questioning that you answered with the Ed puzzle. All right, so um, we have covered this with a previous video and some previous class discussion in regards with segments and rays. And so segments are basically just our parts of a line, segments and rays, excuse me. So if you want to just put a little note, little uh, addition here, these are part of a line, part of lines. Okay, so when we looked at the intro to geometry, we denoted that a segment is a part of a line with two endpoints. It has a start and an end. You kind of drew an example of that on our puzzle notes that we did. So if I'm dealing with a segment, you're going to need to have two, and I'm just going to abbreviate endpoints. Hopefully y'all can see that. I'll change my font on the next one. And then in relationship to array is also part of a line, but it has only one endpoint. Okay, and maybe that helps a little bit. So what we just want to make sure you can understand and see and read off of a diagram is a segment and array. So on our example here, they want us to name three segments from the line. So I know this is a line because I see the double arrow here, but I'm going to go ahead and name this line T instead of with the 2 points that I only need to name a line. Well, because I have more than 2 points here, I can say LP or PQ or LQ. I'm going to do a combination of any 2 points. I'm just going to just indicate line T with the subscript. So I need two endpoints to identify part of a line. So if you want to highlight, I'm going to highlight it here. If I just read my line or the parts from left to right, needing two endpoints, I have this part right here, LP. And so to show that, I would need to put the capital letters, LP, read it from left to right. L would be the endpoint, P would be the endpoint, but I just need to put the segment symbol above it. So don't forget to do that as well. So I have LP. If I go to the next available segment, I have right here PQ. Okay, and so I can add that one, PQ, and then with the segment symbol above it. And then I also have, I'm not sure if you see this, but the segment, and I'm going to highlight it underneath here, the endpoint L all the way to that endpoint Q. So I could also say segment LQ. And just like before, name it with the endpoints, and we put the segment symbol above it. So the line is LT. We know the line is LT because of the double arrows. But since a segment is part of a line, you want to recognize those parts. Okay, so like the part LP here, we have this part um, PQ, excuse me. But if I'm referencing the part LQ, LQ is the part that contains all of the points here. So if I'm looking at the largest segment that I have, which is from L to Q, this would be my whole segment. Okay. And the only reason I'm kind of like making a denote of this is that when we start looking at segment addition postulate or our midpoint postulate, our segment bisector theorem, we need to make sure we recognize that a part, okay, is not going to equal a whole. Okay. And a lot of times, um, there's some misconceptions that are made when you're reading the diagram in relationship to that. Now, on this next set, they want us to do 4 possible rays, okay? For it to be a ray, it has only one endpoint, and then it continues on forever in the other direction or from a direction from that endpoint. So if I'm starting with the endpoint L, okay, I'm starting with this endpoint here, L, I could name the array LP, okay, because I need another point on that line to indicate that I'm pointing or I'm going into the right direction here. Or, because it's going to keep going, right, that. Or I can denote it as, and I'm just going to write it underneath here, starting with the endpoint L, and I could say LQ, okay? I'm putting the array symbol of that. So we name the array indicating its starting point, its endpoint, and then the points that are contained that are going forever in a direction. So I have LP, I could start with the endpoint P here, and when I do that, I can have PQ as array going in the direction to the right here, P2Q, or I can go in the opposite direction. I could have PL as array. And those have separate relationships. If I look at this real quick, my highlight my PQ going that way, and then my PL going the opposite direction. And then I could also have array starting with our endpoint Q over here. I don't know if y'all saw that. And if I do that, I would name going from that endpoint Q, and then I could go to P. And I'm still going to keep the array symbol, even though this array is pointing, let me get my highlighter here. This array is actually pointing to the left. So I'm starting with the endpoint Q. Okay, so I have QP as array, and then I also could have, or I could have QL. But the array symbol is always still pointing to the right. Okay, so the first question is they're asking us is LP, okay, and the key to this to identify that array is paying attention to its starting point. Okay, the first letter tells me where I'm starting with the array. So if they're talking about LP and PL, do they form a line? Well, if I'm showing this, give me a different color here. Let's go this. So from L to P, that's going this direction. That's my blue that I already did right here. And then it says from P to L. The question is, do they form a line? Well, if I look, I can see that they keep extending. So yeah, we would end up having a double arrow here, okay? But the other part is, are they opposite rays? Now, for it to be an opposite ray, for an opposite ray to exist, you have to have the same endpoint. It forms a line, but you have to have the same endpoint. So this actually is no, okay? They are not opposite rays. They are not opposite rays because there is no common endpoint. And the way I find that is if really is in the name of the ray. And I'm just going to abbreviate endpoint N and then PT. Right here, because this ray starts with P and this ray starts with L, I know they don't have a common endpoint. Therefore, they cannot be opposite rays. And I'll give you an example of how that could look. Outside of this, I could have a ray go like this, LP. Okay. And then let's say I have another one going from PL, or let's say I have another ray going from, not necessarily PL, but let's say I go from P to another line. So let's say I go like that. Okay. Let's say PX. Okay. You see how once that extend that ray off of another line, we have several things that are forming here now. We have intersections. We have we actually have angles form, and so in order for it to be opposite rays, it can't be necessarily just form a line, but they have to end up being collinear points. Okay, so in order to have opposite rays, the opposite rays form a line with collinear points. Oh, I'm gonna run out of room here. So if they're collinear points, they form a line with collinear. Sorry, that means that they would end up having to start with the same endpoint. So since there is no common endpoint, this end up having a start. It starts with different endpoints. And what we need for it to be correct is for it to start with the same letter. That's why I go back to putting these arrows to L and P. We need it to start with the same letter for it to be opposite race. Okay. So make sure you kind of recognize that. It's hard for me to kind of extend this basically since I started from L and P on this drawing right here that I did. I would need to start with L and then kind of go in this opposite direction and have another point on there. So it make a line. So I can see those double arrows. Now, planes, I think, parallel lines, we're already familiar. I kind of just highlight the key information on that. They do not intersect. They're always equal distance. Skew lines, we kind of addressed a little bit as well in our table. Okay, there's just for another set of examples for that. So one thing I wanted to show on this first example, because remember skew lines are non-coplanar. Basically that just means not on the same plane. Okay, not on the same plane to be non-coplanar. And then they're not parallel and they do not intersect. So this little yellow parallelogram or quadrilateral is trying to indicate a plane. I'm gonna give it the subscript. Let's see. Here so we can just see that. Now what they're trying to show you is line AB is on the plane, is on the yellow quadrilateral, and this line DC is going through. But what's kind of missing here for that to exist, and sometimes you might need to add this or see this, as these little dotted lines. That dotted line kind of indicates that it's a distance going through in between. So it's just an additional thing that you need to be able to read on a diagram. Now, they want you to list the segments that are skewed to AB. So I've kind of already extend my highlighting of the segment AB. So since this segment AB is on the top of the prism, we cannot pick any segments on the top. So I would see maybe our first example of a segment that is skewed, and also for it to not be parallel, it's not going to go in the same direction, would be over here. This is one. That would be segment CE. Okay, put the segment symbol above that. Then I could go straight to this one, second one here, this green one. We have DF. It's going in a different orientation on a different plane. This is on the right side versus the AB on the top. Then I can maybe pick a plane on the bottom. This one over here. We have HE. Hopefully you see those already. And we also have here on the bottom, GF. Okay. I cannot pick FE because it would end up being parallel or GH. So there are our skew lines to AB. And then our math reading tip. I think you're missing the symbol for parallel. Just make sure you have that. We just want to make sure you know that that is your symbol for parallel. And that's kind of reviewing and reading off a diagram. So now we're going to give you some shapes, some questions, and see if you can interpret a name correctly using the right symbols um, for the different parts or different types of geometric terms. Okay, so on our second page here, we're just gonna give you some time. If you want to pause the video, read and answer, and see if you get to it, this is a great way to check your understanding. I'm gonna go through the first two examples, examples 2 and 3. Make sure everyone's on the right track, and then you will complete the independent practice. Okay, so there are what we're gonna call mini answers, or answers can vary. Um, so if it says name all, they want you to name all. If it says name one, just get one, and then I will check for accuracy. So here, they want us to name all the segments that intersect segment AB. Okay, so here's my segment AB right there. So if it intersects that segment, then it needs to go through that segment, connect, cross, intersect, somewhere. So I can start off easily by just picking the segments that have an endpoint of A, because if it has an endpoint of A, then it's going to go through that segment AB. Okay, so I right off the bat see that I have this segment here. AD would be a segment that would intersect AB. I also have AC, so I'm just addressing all the segments with an endpoint um, with the endpoint of point A on there. So I got AD, AC. I can also do my AT. It would end up intersecting at that point A. And then if I wanted to kind of think outside the box, I'm not sure if you can see that there exists a segment that would be diagonal here, going through the interior and to that point A. So there's also the segment AG. All right. Now I can look at all the segments with an endpoint of a B. Okay, because I wanted to go through over here. So of course, right off the bat, we see BC. It would intersect segment AB. We also have BK. Again, you can do another one intersecting through the interior like such, just like I did that blue line. BH. And then we could do the segment, draw the segment on the top, like they did before as far as BD. So even, sorry, that's a D. So even if they don't, like literally draw it for you, you do want to identify it, draw it maybe on the diagram to help you. Okay, so that's all our segments. I think that's all of them. H. Oh, I forgot. There's one more. There's one on the front. I'm not sure if you can see this one, but if I go from the front face right here to go to H as such, there would be segment H. A. So I missed that one. Or I can also do the one on the side. So there's several here. All right, now let's talk about segments that are parallel to KG. So I'm gonna just clear this off and start on focus. I'm gonna highlight our KG. So this is the bottom segment here, back on the bottom face. So we went parallel to this segment. So I can't right off the bat, we can't do this, right? Because that's gonna intersect. But right after, I can look at a segment that's on the bottom as well. There's one. We can see TH is one of them, parallel. I could go to our segment, the back face right here, BC, would also be parallel. And then kind of like a diagonal segment or diagonal phrase, face would be, if I continue through, would be the AD. So there are three actual segments that would work. Our TH or HT, order doesn't matter when you're naming a segment. You have your BC or your CB and your AD or your DA. All right, and now we want to name all the segments skew to TK. So for that, I'm going to highlight that segment so you can see which one we're going to focus on. So we're focused on this segment here. We want all the segments that are skew. So if you want to pause, like I said, and come back and check, you can. But there are actually 6 segments that are skew to this. Okay, so that segment is on the bottom face of the prism. So I'm going to automatically not pick off of that face. Let's go to the top. So if I go to the top, not in this direction, I can see BC would be skew. AD would be skewed, just obviously horizontal. Um, BD, I know it's not drawn, but it would be skewed to that segment. And then if I go to another face, so it's not on the bottom, maybe let's go to the right side here. Because if I go to the left, I'm going to be parallel. So, and I would end up intersecting. So if I go to the right face over here, excuse me, I see that DH or HD is skewed, and also CG is skewed. And then if I also use the line that was given right here at the very top, the diagonal line, I have AC. So you have at least 6 segments. You can probably draw, no, I did draw the BD one. Yeah, you have 6 segments that are going to be skewed to that line TK. All right, so now we have parallel planes. These are planes that do not intersect, just like parallel lines do not intersect. And when dealing with planes and naming planes, you might want to highlight it just so you can see which face or side they're referring to. So like, let me get my highlighter here. If I look, they want to be parallel to plane PTW. So to get that, remember you need 3 non-collinear points. So if I just trace these points in order, it goes from P to T to W. So if I want to make a triangle right there, that triangle would exist on the left side here in this plane. So I'm just going to highlight that plane so you can see what I'm referring to. We want parallel to that. So right off the bat, just describing it, I know this is the left side of the prism. So to be parallel, I'm looking for the right side. And when I identify that or name it, I need 3 points on that plane. And so I'm just going to highlight it here. So I could go from R to Q to V, and then, or I could say R to U to V. I just need 3 points that are not collinear to name that plane. So I'm just kind of helping you see it visually. This would be plane RQV, sorry, or you could say RUV or VU. There's more than one way to name the plane on the right, okay, or the right side. So if I look at here, they're saying plane SQR. Well, if I follow those letters S to Q to R, I now see that they're talking about the top of the prism. So of course, for it to be parallel, it needs to be on the bottom. So again, our answers can vary here. I could say on the bottom there's T, U, V. I could say also T, W, V. Okay, as long as I'm picking 3 points that are non-collinear. So there's any combination that you can pick there, but they have to be on the bottom for it to be correct. All right, so what's the best thing you have to do, or the best part of geometry is your triangle. You gotta try. So what I want you to do in this section is see if you can name this segment or name the line or the plane based on this pentagonal prism here. And let's see if you're on the right track. The answers can vary. You might see me write that answers, or this little abbreviation may vary, meaning there's more than one answer or combination of an answer. All right, so the first part is they want two segments that intersect segment QU. So right off the bat, we're looking at QU, this segment. We want two segments that intersect this. So there's more than one possible answer here, but to me, the fastest way to get to it is pick a segment with one of the letters, one of the endpoints in the segment. So with the Q or with the U. So if I'm talking about the Q, I could see QV intersecting. If I'm talking about the U, I can have UV intersecting. Or I can say UT. I could also say QR. This is what I'm saying. The answers may vary here when you're doing this. Name all segments parallel to XY. On the next problem here, since we're talking about parallel to XY, that's down here, and that's on the side face here. Well, there's only one segment that's parallel to XY, and that would be TS. Good job. I know y'all saw that. And all segments that are skewed to segment VW. So VW is back here. So these are going to have quite a few answers to it, and they may vary. So I want you to try to complete the try problems in the independent practice. When you get down here, this is true or false. You're just reading and interpreting the diagram, but it does want you to justify your answer, okay? So find either a descriptor or a name of a point or endpoint that helps justify why it's true or false. For example, on the very first problem, it says another name for plane P, and that's using the subscript right there. There's your subscript. Is plane CDF. So I just got to check that plane P is dealing with this horizontal plane. It has to be within this plane. I just got to make sure those points are within that plane and they're not on the same line. So if I look, here's my C, here's my D, here's my F. Would they make a triangle? Yes. So this would be true. And the reason why I can say they're true is these 3 points, there are 3 non-collinear points. So that makes it true. So there's my justification. So that's basically what we're trying to get you to do when we get you to just give evidence for your reasoning for your answer. All right, I know this was kind of intense. Thank you for getting this done while I'm out. We are going to build from this and check your understanding. And if you have any questions, please just shoot me an email and I will get to you then. Thanks.